When you dial this number, an AI picks up and responds instantly. You can speak naturally, pause, or interrupt it mid-sentence, and it tracks the conversation over a speakerphone without the usual delays. Traditional voice bots struggle with natural pacing because of the translation steps. They record your audio, convert it to text, wait for a language model to process that text, and then synthesize a reply back into audio. Every one of those distinct handoffs adds latency. To eliminate that delay, we bypass text entirely. By connecting Twilio's programmable voice directly to OpenAI's real-time API, we create a native end-to-end speech-to-speech connection. To build this, you need 4 things: Node.js version 18 or higher, a Twilio voice-enabled phone number, an OpenAI API key, and the ngrok utility. Ngrok creates a secure tunnel to expose your local server to the public internet. Removing the speech-to-text middleman cuts out hundreds of milliseconds of processing time. That fraction of a second is what determines whether a user stays on the line or hangs up out of frustration with a slow response. Step 1 is initializing the project. Open your terminal, create a new directory, and run npm init to generate a package configuration file. Next, install the specific dependencies. You need Fastify for routing, WS for WebSocket connections, and .env for environment variables. A WebSocket is a communication protocol that allows for the continuous two-way audio streaming required for a phone call. Create a file named .env and paste your OpenAI API key inside it. Storing the key in this hidden file ensures your credentials remain secure rather than being hard-coded into your script. Using a lean stack, just a routing framework and a WebSocket library, minimizes the processing overhead on your local machine. This is the first step in ensuring the audio proxy remains responsive. Now create your index.js file. This file has 2 jobs. It provides instructions for the incoming phone call and maintains the active audio proxy between Twilio and OpenAI. When a call comes in, your server replies with TWIML. TWIML is Twilio's markup language, an XML-based set of instructions used specifically to control how phone calls are routed and answered. 2 TWIML verbs, connect and stream, open a WebSocket audio pathway linking the caller to your node server. Twilio sends the caller's audio in G711 ULAW. Your server instantly transcodes this payload into PCM16 for the OpenAI real-time API. The response follows the exact same path in reverse. OpenAI streams PCM16 audio back to your server, which re-encodes it into ULAW and pushes it to Twilio. Warning tone. A common point of failure is a silent connection. This happens if you fail to enforce the strict audio/PCMU output format in your code, which must match Twilio's expected encoding. Mastering this bidirectional format conversion is what makes a real-time conversation possible. If the encoding and decoding don't happen perfectly in the proxy, the audio stream will break. With the code finished, you have to handle the networking. Twilio is a cloud service, which means it cannot send data to a local server that is closed off from the public internet. Boot up your application by running node index.js. Confirm in your terminal that the server is listening on the port you assigned. Open a separate terminal window and start ngrok. This creates a secure tunnel through your local network and provides a public HTTPS URL that points back to your machine. Copy that ngrok URL and log in to your Twilio console. Locate your active phone number and find the webhook field labeled "A call comes in." Paste the URL into the field and append the /incoming call route to the end. Without this specific path, Twilio cannot find the TWIML instructions you wrote earlier. Once you save this configuration, the global telecom network is connected to your local code. Every incoming call to that number will now trigger your script. To test the system, dial your Twilio number from a physical cell phone. Check your terminal for the connection logs. You should see an incoming request followed by a confirmation that the media stream is active. Talk over the AI. Because this architecture uses server-side voice activity detection, the AI stops talking the moment it hears you. This allows for the same natural interruptions you would have in a human conversation. Watching the logs populate while you hear the audio confirms the sub-second response time. This proves the audio proxy is successfully bypassing the delays of a traditional text-based bot. You now have a working AI voice assistant capable of managing live audio streams on a standard phone line. This comparison of the economics shows that the baseline telecom routing is a fixed cost of less than a cent per minute. Your primary expense will be the usage-based AI tokens consumed during the call. You can now modify the system prompt to change the AI's persona or integrate tool calling. Tool calling allows the real-time API to interact with external databases to execute tasks like looking up customer records or booking appointments. Removing the latency changes the dynamic of the call. Bypassing text translation provides the response times needed for natural back-and-forth dialogue.